So this is a project which I call the Biscuits Project for reasons which might become obvious. This actually started with a bit of art that was shared many years ago, where an artist was taking places like Paris and slicing them into little bits and kind of showing the structure by laying it a different way. I quite liked that, and being a programmer, I thought, I wonder if I can automate that. So the last 3 years, I think I've been working on this on the side, has effectively been trying to answer that question. So what does it look like? So I did a first attempt, which was kind of effectively treating a map as a bitmap, and then finding connected areas, and then slicing them up, doing that. So I did that with OpenCV. It kind of worked, but it was a manual process where I was literally screenshotting a map, running it through OpenCV with some Python, and then dynamically putting it back together again. But the question was, or my thought was, all right, okay, that's cool. It doesn't totally work. How can I experiment more easily in a more dynamic way? So that's where this comes in. So I'll introductively reveal this. So what we're starting with here is some maps that are based on Mapbox. This is basically just drawing the Mapbox streets layer back onto the map. The overall algorithm is that we add streets and we add water. And then what we want to do next is say, okay, for those black bits, can try and connect those into segments, which is where Rust comes in. So I shall switch to my browser, switch to here. Okay, so this is the quick thing of I won't probably dwell on this too much. This is basically how you load WASM into this particular app. You have to load WASM as you can't import it directly. You have to load it. Better term for this out, but load it lazily as an import. This is just some kind of like gubbins to make that happen. And then the thing that you saw there is basically this kind of code here of saying, okay, use some non-Rust code to draw the shapes as a bitmap. The Rust then comes in. The Rust then comes in to work out what are the connected segments. So the other thing I was interested in was that in OpenCV, there's a thing called region labeling. Technically, I think you could make OpenCV work in the browser, but again, it's wrangling with C. So I thought, can I do this in a pure Rust way? So there's a library called ImageProc, which is implementing a subset of the stuff that's currently in OpenCV. So first I started off with saying, okay, can I use that? And surprisingly, it actually worked quite well. So the main thing I'm doing here is that I'm using the existing region labeling code. I made a small contribution to make it work on WASM, which just involves updating a couple of things, but it pretty much worked out the box. That then gave me the region labeling, and then I wrote my own code to implement a simpler version of connected components of then taking those bitmaps and then drawing contours around them. So the main things that are happening in Rust are finding the connected components in the bitmap and then turning those connected components back into shapes. And the key thing is that was made possible to run reasonably fast. So let's go back to the browser. So once I turn this on, so this is the thing coming back from the Rust to take those bitmaps, randomly color them. There's no significance in these colors; they're purely random, and then it's fast enough. I wouldn't say it's ridiculously fast, but it's fast enough that I can do things interactively with it and play about with stuff. So the key thing that Rust did here was that, and WASM in particular, was that it allowed me to use some existing libraries that probably wouldn't be particularly robust in JavaScript and run them fast. I've then exploited Rust further by doing things like there's some calculations that previously were in the JavaScript. It was quite easy for me to take them and then run them in the Rust, and it got easy speedups of like 100 milliseconds for things like iterating through an array and resizing some stuff. Okay, that's the end of my presentation. So